Hello world, today we are going to solve a question from Harvard University's admissions in the field of mathematics. So let's start. It is given that a triangle has sides of lengths 3, 7 and 8 and it asks for the probability of the randomly chosen point in a triangle that has less distance than 1 to at least one of its corners. So this part is really important. After reading the question, we can basically think about a probability problems equation, which is just the favorable over the total. After that, we can basically draw a triangle. And then input the points here. And after that, also the measurements. So, if we think about what is the total possible situations in this kind of problem, since the point is going to be inside of that triangle, the area of the triangle would be the uh, total possible locations that the point could be located in. So we can just mark the area of the triangle as the total possible points, just like this. And then after that, we can just draw some circles with their radius being the distance, their distance from the corners, which is going to be helpful while locating the point that has at least less than a distance of 1 to the corners. Yeah. So after that, if we think about the angles here, we can label them by giving x, y, and z. So after that, if we think of this right down there, because this is a triangle and we also have the outer we also have the outer because this is a triangle and we also have the outer angles there, it is obviously seen that x plus y plus z is equal to 180. It is so because this is a triangle and we also have the outer angles, it is obviously seen that the sum of x, y, and z is equal to 180 degrees. So after determining this, we can just say that if this were a circle, half of this circle, the area of the half of this circle would be is going to be the favorable points that the actual point could be located inside. So if we were to calculate the area of this half circle with a radius of uh, 1, because it says less than 1, less distance than 1. So remember the formula. So this is the formula of an area of a circle, so that the half area of a half circle would be equal to pi times radius squared over 2, which is in this case equal to pi over 2. So we are about to approach to a point where we have to remember a formula. Oh, wait a second. Okay. So here we have to use the Heron's formula to determine the measure of the desired point. So let's remember the formula. Let's say u is equal to 3 plus 7, sorry, 3 plus 7 plus 8, which is equal to 18 in this case. And then after that, u divided by 2 is equal to 9. So the area of a triangle would be in the square root of 9 times 9 minus 3 times 9 minus 7 times 9 minus 8. If you don't know the formula, you can look for the proofs and then come back to our video and then watch it again. So what we get here is equal to, this part is 6, this is 2, this is 1. So it's equal to 108, which comes out as 6 root 3. After this point, we can just plug the values inside of the probability formula. So the probability is pi over 2 for the favorable, and then 6 root 3 for the desired. So if we take this through to the denominator, it is going to be equal to pi over 12 root 3. And then after that, if you multiply both of the denominator and the numerator by root 3, it is going to be equal to pi root 3 over 36.